we can combine the chain rule with product and quotient rules. We can now build functions using any combination of arithmetic and composition that we like. It's important then that we recognize when we need to use which rule. So I've got this lovely function up here. Y is sine of cosine x over sine x times cosine x. Now the top and the bottom look fairly similar because they both involve a sine and a cosine, and sometimes students will get these confused. They see the sine next to the cosine here on top, and they want to think that means multiplication, but it doesn't. The top here is composition. Now, one way to tell is that functions have to have an input. What am I plugging into cosine? X. I don't see an x after the sine. That is not sine x being combined with some other function. What's plugged into sine is cosine of x. If you only see one x in your expression, it's not going to be a product of two functions unless one of those functions is constant, because you only have the one x. So that's often a sign that you've got function composition. Compare that to the bottom. Right after sine, I've got x. And right after cosine, I've got x. So that denominator is a product. So when we're taking the derivative of the top, we'll be using the chain rule. When we're taking the derivative of the bottom, we'll be using product rule. And of course, the whole thing is a fraction, so the whole thing is a quotient, so we're using quotient rule too. Good time to practice our bookkeeping. So y prime, using quotient rule, we get low sine x cosine x d high times the derivative of sine of cosine of x minus high sine of cosine of x d low times the derivative of sine x cosine x all over square the bottom, and away we go. If I'm squaring sine times cosine, I'm squaring each factor. So I'm just going to write that as sine squared times cosine squared. So now let's go back and evaluate some d by dx's. So this is going to be sine x cosine x times. Here, this was the derivative of the composition. So we're taking cosine, we're plugging that into sine. The derivative of sine is cosine. And I'm going to evaluate that derivative at the same thing I was plugging into sine. So it's going to become cosine of cosine x times the derivative of that inside part. Notice, just like this was not sine times cosine, this is not cosine squared, that's cosine of cosine x minus sine of cosine of x times this derivative. This one was the product. So I'm going to put in some brackets so that I can say the whole product rule, both terms, is getting multiplied by sine of cosine x. So we'll have the derivative of sine x times cosine x plus sine x times the derivative of cosine x. And then that's still over sine squared x, cosine squared x. Excellent. So I still have some d by dx's to evaluate. So let's see. Just bumping up here, sine x cosine x times cosine of cosine x times the derivative of cosine is going to be negative sine x. All right, minus sine of cosine of x times, in brackets, because this was the entire product rule, the derivative of sine is cosine, and that's multiplied by cosine. So both of those have an x. That's cosine x times cosine x, plus sine of x times the derivative of cosine is negative sine x, all over sine squared x cosine squared x. Now, I am going to do just a little bit of simplification to avoid making careless mistakes if I were to go any further with this. If I'm multiplying by something negative, I really prefer not to have things written with that negative sign in parentheses like that, because if I get careless and I drop those parentheses, it's going to start to look like subtraction. So I always like to rewrite things by bumping a negative to the front of that term. And then I'm also just going to observe that that's a sine x, and that's another sine x. So that I can say they're both sine evaluated at x. I've got two factors of that. That's sine squared x, then times cosine of x. That I can't combine with anything because this other piece is cosine evaluated at cosine of x. So I basically have three factors now. Sine squared x, cosine of x, and cosine of x. Okay. Minus sine of cosine of x. In these brackets, I'm going to just do the same thing. I'm going to bump that negative to the front of this term. Not to the front of the whole thing, because the negative doesn't apply to the cosines. I can write that, since each cosine is evaluated at x, that's cosine squared x, and then it becomes minus sine squared x all over sine squared x cosine squared x. Okay, certainly if I wanted to, I could distribute that division. I could try to simplify things further. If I wanted to find a second derivative, it might be worthwhile to do that and see what was going to be the simplest. I think I'm going to stop here.